Hello everyone and welcome back to the hardware channel. Today I want to show you a very interesting application by using the NE555 as a GSR device. Don't know if you are familiar with the term GSR. It's an abbreviation that stands for Galvanic Skin Response. And this is a device that measures the conductivity of the human skin. Today this term is not frequently used anymore. As far as I know, it's replaced by the term electrodermal activity. Electrodermal activity is determined by the activity of the sweat glands inside your skin that are embedded in your skin. And sweat is containing water, that means humidity, and dissolved minerals, so that means it's more or less salty water. And salty water has a good conductivity, so that means the amount of sweat going through your skin, passing through your skin and lying as a film on the surface of your skin specifies its conductivity, or the impedance, which is a reciprocal of the conductivity, of course. So, and measuring the skin is possible by a GSR measuring device, which is, for example, an ordinary ohmmeter in the most simple approach, or you have something with like a Wheatstone measuring bridge with an additional amplifier that makes the signal readable. When you're using the NE555 for this purpose, it's a little different, because the NE555 doesn't contain anything of all those things I just told you. The NE555 is a device that generates impulses, and it does so by using, or let's say the other way around, the length of the impulses is specified at first by the value of a capacitor, and second factor is the value of a resistor. Those both factors specify the length of the impulse. So if you replace the resistor by a human skin, you get a device which generates impulses, and the length of the impulse depends on the conductivity of your skin. So the NE555 converts the conductivity of the human skin into impulse lengths, and an impulse is something that is half on the way into the digital world. It can easily be sampled or counted. Its length can be counted. So it's for a computer, PC system or microcontroller, there's no problem to count the length of the impulse and to make it readable as single values, for example, on a wave chart, something like this. And I want to show you my first approach now by starting with the schematic. So you see the schematic is quite simple. It's just a hand-drawn blueprint now. I didn't make a schematic on my schematic program yet. So this is the NE555, there's nothing special here. The standard decoupling capacitor between the supply voltage and ground. As you can see, the trigger input is wired to the threshold input. This is the standard wiring method when you want to run the NE555 in the R-stable mode. That means it is oscillating. And here's the capacitor, a 1 microfarad capacitor, the first factor that specifies the impulse length. And you can see that resistor is replaced by this one here. This is just for safety purposes. And these two plates here that had to be connected to your human skin. In my approach, these are small copper sheets of copper. I'm fixing to my fingers by using a duct tape. This resistor here is just for safety reasons, because when you are short-circuiting those plates accidentally, then a lot of current flows here into the capacitor and maybe into the device. So I decided to bring in this small resistor that doesn't change the readings or the impulse length remarkably, but gives some more safety against this short circuit here. Okay, and what you get here on your output are trains of impulses with a dead time of 10 milliseconds. The dead time is specified by this resistor here, because when the NE555 discharges, this pin here is going to ground, and the capacitor is discharged to this 10K resistor. And because this is a constant value for the resistor, also means that the dead time here is constant. And decided to make it 10 milliseconds. It's large enough for a sampling system to detect that the pulse is over. And the main pulse here, which is taking the original reading of the conductivity, is this one here, and the impulse length, due to my findings, is varying between 20 and 80 milliseconds. This is the variation you can get between a good and a bad conductivity on your skin. And now I'm going to show you how this works in... Okay, this is my breadboard setup here, and as you can see, these are the plates I explained you a few seconds ago. Here are the copper sheets, and they're soldered to these wires, and I easily can apply and fix them by using these straps around my fingers. And I found out that 2 fingers are a good position for taking the conductivity readings. Okay, it's fine, feels comfortable. Okay, and as I told you, here's my breadboard, and you can see there's nothing special here, just a few elements. The NE555 is placed here. We also have the power supply engaged to 9 volts, and so let's take a look at the scope readings. Okay, I hope you can see the scope readings. Now I'm trying to keep relaxed as far as possible, and you can see that the conductivity or the impulse length is varying a little bit up and down. And one thing I observed, which is kind of funny, when I deeply breathe in, then the impulse length shrinks drastically. I'll try to show you this now. You see it? This seems to be some kind of neurophysiological response to the expiration process, maybe. Now I take this this needle here, and I'm gonna put it on my skin to give it a little pain, and let's see if we can see a change in the conductivity. I will apply the needle now, and you can see it hurts really, it hurts so bad, it hurts so bad. Yes. You see a dramatic shortening of the impulse. Now I took away the needle again. You can see the impulse is enlarging. So shorting the impulse means the conductivity is rising, or the impedance is going down. That means more sweat is emitted, which seems to be logical in a stress situation. I think there are a lot of more things to discover. The next step to go will be to put this little device into something like a prototype and then connect it to my overall system and write some program to show those readings as a wave chart, and maybe with the possibility to store it on disk, and then I will tell you something more about it. Okay, that's all for now. Thanks, and see you again.